this right here. That, I don't know how you can stick it here on this. This is strictly cool aerosol setup. There's no way. Now notice the difference in the head. This part we call the neb head, right? This is the head. You put this in sterile water, you know, and go from there. If you see chrome, remember it's aluminum. It's not for looks, it's to heat. So you come over here and just imagine that there is like a bottle of water right here. Voila. Flow meter screws on right here, right? And you got your heater. Same thing with this. So we call this a wraparound or yoke or donut heater. Those are a little bit older. This is probably what you're going to see. So this would go through here, and we wouldn't even be using the aluminum portion on this. There. I can actually think this will fit. You would have like a bottle that would either screw on like this, or if you look, you could screw on a bottle with like a neck type thing. So there's two different types of bottles you could screw on here. So it's heated through here. Gas flow as it goes through here is heated. Now, anytime you heat, you need to make sure you're not heating it too much, right? So when we use like a fancy dancy heated humidifier right here, it's got a wire that goes and acts like a thermometer, which it is a thermometer, to give basically the signal to this to determine how much heat you want right before it goes to the patient, right? It's like a temperature sensor. Well, we don't have fancy temperature sensors with aerosol delivery usually, but we can use a cheapo depot thermometer in line. So if you're using a heated aerosol that doesn't have a fancy wire with a electronic thermometer, you still, if you heat it, you gotta know what the temperature is. So this thing goes up to like 40 degrees. Do we want to give 40 degrees to the patient? Yeah. So, and it'll give you a number here too as that temperature increases. So somewhere between 30, 35, probably with a heated aerosol. You just stick it in line close to the patient. So the mask, or the face tint, or whatever would be right here, connected to this. Cheesy enough. There you go. You want a picture? That's a baby trait. So, something to that effect. All right. Moving on. We doing okay, or y'all need a break?
No,
We're good? All right. So if I'm hooking up a large volume neb for bland aerosol, I need a neb of some sort. I guess I should show you how this is put together, because they use these around here. So this ends up being packaged in plastic together, all right? And sometimes this, I think this may be separate, but it's in the same bag. So you take it out. This is sterile water. There's no puncture holes here, but notice this will puncture the top of this as you screw it on. So you screw this on until it's pretty snug, and then you take this has got a little sharp point to it too, and you puncture it right there. So this acts as that capillary tube, right? And this will draw in liquid into the jet. Remember, the jet you can't even see, and what you're manipulating is the air entrainment window, right? So it's working off the Venturi principle, right? All right. So this is going to be hooked up to air or to oxygen.
It's air.
If it's air, I mean, all you're giving them is 21% humidified, you know, air. If it's oxygen, then you can give anywhere from like 28 to 100%, noting that after you get up over 40%, your total flow drops dramatically, right? The closer you get to 100%. So you have this on your oxygen flow meter, and you're gonna go and you're gonna get some tubing. Now the tubing used to be in like a big container. We'd pull it out and cut it. Nowadays, most places it's pre-packaged. Did they take my packages? No. Maybe they did open them. Oh. Just imagine it's packaged like this, and it's packaged in 5 feet, sometimes 6 foot lengths.
That's in the package.
Yeah, it'll tell you what's on there. Sure, I might have some more laying around here. So let's just pretend. I think this is 1, 2, 3, 4, 5, 6. This is like 3.5 feet right here. Yeah. So let's just pretend these are 4 or 5 foot lengths, pre-packaged. So if you're setting up, let's say, an aerosol mask for the patient, I need an aerosol mask, I need aerosol tubing, and I need a water trap. Now, look at these water traps right here. Versus like this water trap. Which of these does not look like a high pressure water trap?
Bag.
Yeah, so which do you think's cheaper?
The bag.
The bag, right? So it's almost just like a balloon with a little, can hold more moisture, but it's like, balloons can only be blown up so much and pop, right? Mm-hmm. So this would not ever be a type of drainage system that you would use for a high pressure system like a vent circuit or BiPAP or CPAP. These are what you would use. Now your boss doesn't really want you to use these in an aerosol setup because these cost more, and these are what we use for that, not for this. So you want to get the right piece of equipment. So this is an aerosol drainage bag, and you put it together something like this. The hard part is doing it all aseptically and all that stuff. So you're going to put this here. Don't cram it on. And I'll explain in a minute. Oops. Put it on there enough where it won't flop off on you. But you can get a general idea what this is going to do here, right? So this is going to go something like this.
Oh, okay. Yeah.
All right. So I'm going to put this mask on. Cram this on. I need to show you how to cut tubing too. Somebody jacked this, they didn't cut it right. Support, right? Support your equipment. Put that on there. Have it at the right FiO2, the right flow, right? How do you do that? Total flow, right? And then we would put it on the patient. Of course, you've already told them why you're there and all this stuff. All right, Miss Smith. And apply, of course, the gas is flowing, right? Never put a mask on and not flowing. Now, this isn't the greatest example, but it's a good thing to look at as far as what to do wrong. So, you got the gas flowing here. Where is all the liquid condensation going to form? Right there.
Right where.
Right here,
Yeah.
right? So you've basically made this useless. Okay? So you're gonna cut and adjust this so that the lowest point is where the thing is. So in the good old days, and if you still have work someplace that does it like this, then I get about 10 feet of tubing, supposedly between this point and this point is approximately 6 inches. Just pointing this point, between the middle point of each of these. See how that's got corrugated tubing and then solid? So the middle of that solid and the middle of that solid is supposed to be about 6 inches. Now, if you know your height, about between here and there is half of your height, between here and there. So that's about 3 feet. And then that's about 6 feet. You see where I'm getting at? 9 feet, and then so forth. So I would get about 10 feet, give or take. And let me redo that since I'm gonna start with 6. And then we'll go about right here. And then I'm gonna cut this. Now, when you cut aerosol tubing, don't cut here. Only cut in the middle portion of this. Like whoever just cut that one, cut down here. And that's slightly decreased diameter. It's more difficult to cram something on. That's what I was having difficult. So cut right in the middle. To get a clean cut, push. Make it flat, right? Find that little line, push right there, and then cut.